Hello guys, welcome back to Coding with Bobby, and today we are solving the bi-weekly contest 126. This is the last question, the hard one, which is of the recursion, we can say, or the DP, dynamic programming. So now the question is, we are given an integer array nums of length n and a positive integer k, and the power of an array of integers is defined as the number of subsequences with their sum equal to k. Return the sum of power of all subsequences of nums. Okay, since the answer may be very large, you return it with this modulo. Okay, fine. So we'll take this example 1, 2 and 3, and we have got k equal to 3. So we need to find out number of subsequences whose with their sum equal to k. Fine. Okay, so we have got this. They have taken this subsequence is you can remove any number of elements from anywhere, and that will give you a subsequence. Like 1 and 3 can make a subsequence. Subarrays, you need to have a contiguous subarray, contiguous elements, right? So if we take 1, 2 and 3 like that, so in this subsequence, this is one subsequence, right? And this is one subsequence, 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 and this, right? 1, 2, 3, 4, 5, 6, 7. Yeah, so we have got these many subsequences. Have we left any? 1, 2, 1, 3, 2, 3, and 1, 2, 3, right? And 1, 2, 3. Okay, yeah. So what we'll do now is, see, in this subsequence k equal 3, so we have got this has k equal to 3, and this subsequence has one you can say one integer, or has some pair which has its sum equal to 3 equal to k. So this is 1, so we'll have it 1 plus, right? And if you see there is 1 and 2, if you just combine these 1 and 2, this is also one subsequence, you can say, inside this subsequence, right? So inside this subsequence we have got two subsequences who have got their sum equal to 3, right? So 1 plus 1. Now inside this, yes, 1 and 2 has a subsequence, 1 plus 2 is 3, so it has got 1. Now here, yes, this has got 1, 3 is there, 1, this also has 1, 3 is there. Now this doesn't have, now this also doesn't have, and this has 1. So 2 plus 3 plus 4 plus 5 plus 6, 6 is our answer, right? So before we go into this, there's one more thing we need to consider here. The total number of subsequences that we can have if we have an array of n elements is 2 power n minus 1. Like if you see this 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2 and 3, 1, 2, 3, 4, 5, 6, 7. So you can have these number of subsequences always, right? So this will be very helpful for us later on while we frame the solution for it. And if we take the other example also, 2, 3, 3, okay, 2, 3, 3. So first we'll have we'll write down all the subsequences, 2, then 3, then 3, then 2, 3, then again 2, 3, this 2, 3, right? And then this 2 and the last 3, and the k's are 5. So 5 can't be found from here, same here, no, and same here, no, and here we have got 1, which is our 2 plus 3, and here also we have got 1, which is our 2 plus 3, right? And I forgot to write, there is one more to it, 2, 3 and 3, and there is 3 and 3, right? 2 more, yeah. So in this, if you closely observe, this has two subsequences which has sum equal to 5. Now 2 plus 3 is 5, and this 2 and this 3 also equals to 5, so 1 plus 1, and this doesn't have, right? So we have got the answer as 4 here, right? You can see. And in this case you can see the total sum, if you do 1 plus 2 plus 3, that is 6, so you can't achieve 7 any time, right? So this question becomes a sort of like knapsack. What we can do is, if you see the constraint also, it's not very tight, we have just got till 100. So what we can do, like if we move from this index currently, we can have two choices, like whether to consider this in our sum or not. If we have considered, suppose I move from 1 and I consider it in my sum, so my sum so far is 1. Now I go to 2 and I consider this also in my sum, so 1 plus 2 is 3. Now I've got k equal to 3. Now with this pair I've got my sum. Now I need to find this, considering 1 and 2 as together, how many subsequences can be there, right? So I was on 1, 2 and 3. Now I was traversing from 1, right, and then I took the choice that I'll take this in my sum, then I took the choice I'll take this in my sum, so I've got my sum 3 here, right? So what I'll do is, I need to find out how many subsequences can be formed with this 1, 2, considering it as 1, right? So the easiest part is, if you see here, this 1, 2 can be a part of this subsequence, right? And this 1, 2 can be a part of this subsequence. So this can be a part of only two subsequences, right? This 1, 2. So now, how is there any formula how we can find that out? Yeah, there is. So how we get to that? If you see 1 and 2, this is consisting of two elements. Now you see, so these two elements, so now we are left with how many elements in this array? We are left with only one element. So if you do 2 power 1, which will give me just 2, right? Which will give me just 2. So there are only two subsequences which have this, right? So this formula comes into place here. Yeah, the actual total number of subsequences is -1, but if you closely observe here, we are doing like we have got two elements, we treat them as 1, so now we have got only one element left in it. So 2 power 1 is 2, and if you'll do -1, then this will only give you this one, right? We are not considering this. So to add this one also, you can just remove this -1. So we have got 2, right? And we'll take some bigger example also. Suppose I've got 1, 2, 3, 4, 5, right? And now my k is equal to again 3. Now I'm traversing 1, I take it in my sum. I'm traversing 2, I take it in my sum, right? So now I need to find out how many subsequences this 1 and 2 can be a part of, right? So how can I find that? 2 power, how many elements I've taken? I've taken 2, so how many are left? 3. 2 power 3, that is 8 subsequences. Now let's find out those 8 subsequences. 1, 2 would be there. So first we'll take 1, 2, 3, then we'll take 1, 2 and 4, then we'll take 1, 2 and 5, then we'll take 1, 2, 3 and 5, then we'll take 1, 2, 4 and 5, then we'll take 1, 2, and what else is left? 3, 4 and 5, and yeah, one is single 1 and 2. So we've got 8. 1, 2, 3, 4, 5, 6, 7. Okay, am I sure? 1, 2, 3, 4, 5, 6, 7. Okay, have we left any subsequence? We have got 1, 2, we have got 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 2, 3, 1, 2, 4, 1, 2, 5. Now the next we have got, we have kept this as constant, 1, 2, 1, 2, 3, we have got 5 directly, and we haven't taken 1, 2, 3, 4, right? 1, 2, 3 and 4. So we have got 4 subsequences here, right? And now these all subsequences has this 1 and 2 in that, and this 1 and 2 result to k equal to 3, right? So this is our actual formula that we are gonna use, right? And if you take this example, like 3 is there, right? So suppose I came on 3, and suppose I've not taken this element, because every time in recursion I'll be having two choices. I take that, add up in my sum or not add up. So I take the choice of not adding it, and then I add it. So now my sum becomes directly 3, right? So now I have taken just one element, and that is 3. How many elements are left? We are left with 4. So we have got 16 subsequences, and yeah, we will get 16 subsequences for this, in which 3 will be one part, right? So this is how we'll approach it. I'll directly jump you to the code. Okay. So for calculating the power, instead of using mat.pow, I've used this efficient power method, and in which I'm also doing the mod part, right? If you're not aware of it, I'll just give you a glimpse of it. I'll just show you up here. Suppose we need to find out 2 power 5. So in this, how can we find out? I'll take res, which is 1 for now, and n is odd. Yeah, n is odd, so res will become res 1 into 2, that is 2, right? And n will become 4 now. Now next time n is even, so I'll not touch result. I'll just do x is equal to 2 into 2, which is 4. Now n becomes 2. Now next time again n is even, so I'll again do this. So x will become 4 into 4, that is 16. Now n becomes 1. Now n becomes 1. Then what we'll do, we'll come to this even part, odd part, and my result will become res was 2 into x, that is 16, is equal to 32, like that, and then will become 0. This is known as exponential power calculation, right? So this you can use for power, and TP we'll consider it later. Right now we are just using this fun function. I've sent nums, I've sent k, and I've sent index on which we are, and I've sent how many elements we have taken into count right now, and that's it, right? So what I'll do, if my k becomes 0, that means see what I'm doing here, I'm actually doing k minus the nums. So if my k becomes 0, that means the sum has become equal to k. So I'll just return this power of 2 to the power number of elements that are left, 2 to the power like 3 we did. So nums minus count of elements that we have taken into account. Now if index becomes greater than nums.length or k becomes less than 0, then we need to directly return 0, right? Now this take shows us that we are considering this element in our sum. So nums k minus, and we'll do index plus 1, and we'll also do count plus 1. Now if I'm not considering it in my sum, in that case k will be same, index will increase, and count will be same, will not increase count as well. And the final answer will be take plus not take mod. Now we'll add dp. Now to add dp, we'll see k is changing, idx is changing, and count is also changing. So we need to take a 3D array, and so the 3D array would be something like k. For k I'll take k plus 1. For nums.length, idx can be up to nums.length, and count can also be till nums.length. So like that, and I'll fill everyone with -1, and I'll just check here if dp k, idx and count not equal to -1, we'll directly return it. Otherwise we'll set the value and return it like that, and we'll just submit it once. Yeah, it works fine. So if you have got any doubts in it, just let me know in the comments. Thank you.